Hey guys, let's go over this FRQ about neurotransmitters. But let's first go over this graph we have here about action potential. So if we remember, on the y-axis it is the membrane potential, which is measured in millivolts. And so that is caused by the different ions on the inside and the outside of the neuron. And so on the x-axis, we're looking at time in milliseconds. So these action potentials are happening very quick. So remember that when we have enough stimulation, that we're going to create, let me use my pen, that we're going to pass the threshold. And once you pass the threshold, usually happening at the axon hillock, the amount of sodium is going, the amount of sodium is going to start to rush in, and it's going to cause a depolarization. So remember that if we're talking about this side of our graph, we're going to remember the words depolarization. We're going to remember sodium rushes in, and then it's going to reach this the maximum, and it's going to then drop back down. And so when we're talking about this side of our graph, remember that it becomes so positive on the inside that the potassium starts rushing out. And here, this is our falling phase. And I should have included this. This was our rising phase. And when we reach down here, we are becoming hyperpolarized. Hyperpolarized because we are moving further from zero. So this is neutral, and we are, on our depolarization, we are moving closer to neutral, and on our hyperpolarization, we are getting further from neutral. And so here, describe the immediate effects of the neurotoxin on the number of action potentials in a postsynaptic neuron. Predict whether the maximum membrane potential of the postsynaptic neuron will increase or decrease. So here, it will increase the number of action potentials. Yes, this should make sense, because if we increase the amount of acetylcholine, so remember this is our acetylcholine out here, it's going to cause a stimulation, and then the stimulation is going to cause the Na plus to rush in, and then an enzyme is going to break down the acetylcholine. And so if we have enough sodium going in, we're going to have an action potential. So if we have more acetylcholine, we're going to cause more action potentials. And however, it says, will the maximum membrane potential increase, decrease, or stay the same? So this is the maximum potential. This is going to stay the same. Remember that we have factors that create the resting potential. There are the sodium ion pumps, the sodium potassium pumps are going to be regulating the amount of ions in it going in and coming out. And also we have leak gates. And so once it becomes too positive on the outside, then negatives are going to start rushing out, or vice versa. So there are regulating factors in there that are going to keep the maximum membrane potential about the same. So here we are at part B, and so we're talking about the enzyme acetylcholinesterase, which is working out here to break down the acetylcholine. And so the question asks us if we put the acetylcholinesterase on either the inside of the neuron or the outside, so the synapse of the neuron, is it going to prevent the effect of the neurotoxin? And so the neurotoxin, what it does is it creates too much of this acetylcholine. And so we want to reduce the amount of acetylcholine so that we aren't overfiring this synapse. And so in order to reduce the acetylcholine, we need to put the acetylcholinesterase in the synapse, because the acetylcholine is not going into the neuron. It is in the synapse area only. So if we were to put it in the cytoplasm, it would have nothing to do. You put it in the synapse, and it's going to be busy degrading acetylcholine. I hope that makes sense, and let me know if you have any questions.